The sun is around 4.5 billion years old, and just like you and I, it's aging. In just over a billion years, the sun will have expanded so much that the heat will begin to melt the Earth's surface. So, is there any way us Earthlings can avoid this detrimental event? Can we save ourselves from the sun's ultimate death? Sure, none of us will be here, assuming we don't find the secret to everlasting life, but at the billion-year mark, the sun will have used up the hydrogen fuel in its core, forcing it to burn at its surface. The increased radiation will boil away all of the water on Earth, creating an international desert. Flash forward about 5 billion years, and the swelling sun will begin literally melting mountains, with most, if not all life on Earth now extinct. Around 7.5 billion years, the expanding sun, now a red giant, will engulf the Earth entirely. Sounds bleak. So can we avoid this hot mess? It turns out our best bet lies in something called gravity assist, a technique we've been using for years only to launch spacecrafts throughout our solar system. Anytime a spacecraft or satellite comes in close proximity to a planet, gravity grabs hold. And if the spacecraft arrives at the perfect angle, it's able to use some of the planet's velocity to catapult it further into space. This extra energy comes from the planet's own energy of motion around the sun. But as Newton famously said, to every action there is an equal and opposite reaction. As the spacecraft uses the Earth's gravity to speed up and move towards Earth, the planet will ever so slightly slow down and move towards the spacecraft. Of course, the spacecraft's mass is so small comparatively that it gets launched incredibly far while the planet experiences little change. But if we were to increase the spacecraft's size, or use an asteroid, we could potentially move the Earth's orbit away from the sun. This would take millions of years and involve large objects coming just close enough to not collide with Earth. But hey, we've got a billion-year head start. It may seem far-fetched, but it's already happening. On October 9th, 2013, Earth will be used to gravity assist a spacecraft called Juno, which is on its way to Jupiter. As Juno flies within 559 kilometers of us, it will use Earth's gravity as a slingshot to boost its velocity by 7.3 kilometers per second. Meanwhile, Earth will have been moved by a fraction. Juno will later arrive at Jupiter in 2016, where it will study the interior of the planet and help to unveil many new spectacular mysteries of our solar system. In order to move the Earth within our billion-year timeline, we would need approximately one encounter every 6,000 years using an object with a mass of approximately 10 to the 19 kilograms. That's 19 zeros, somewhere around the size of a 100-kilometer wide asteroid. In between passes, the asteroid would slingshot around the sun, fly out to Jupiter, and then be gravity-assisted back to Earth, like one long version of Catch between planets. Over millions of years, this would move the Earth to a comfortable 225 million kilometer orbit out from the sun. And while it is feasible, even with today's technology, it doesn't come without risks. For one, we may lose the moon, which could ultimately create some extreme weather patterns. Not to mention, the Earth's spin may increase, making days only hours long. The surrounding planets, like our new neighbor Mars, would likely have their own orbits destabilized. And, the asteroid could come plummeting into Earth by accident. But perhaps these are the risks we need to take to give our descendants, the planet, and all life on it a few extra billion years. Got a burning question you want answered? Ask it in the comments or on Facebook and Twitter. And if you want to learn more about Juno, check out its awesome interactive website we've linked in the description. Special thanks to NASA for inspiring and supporting this episode. And subscribe for more weekly science videos.